Hi, I'm Lim.
Hi, I'm Kanishwaran, and we are the co-founder of MagnaTex, and we are from Johor Engineering Matriculation College. And in our college, many students struggle to visualize and comprehend the direction of magnetic field and the motion of charged particles in a uniform magnetic field. Traditional methods such as a textbook diagram or theoretical explanation often lack of interactivity and intuitive engagement. To overcome this, we are developing two simulations under MagnaTex designed to help students explore magnetic fields and charged particle motion in a more interactive and immersive way, which suits the matriculation syllabus.
Okay, without further ado, let us dive into the demonstration of MagnaTex. So as we can see here, this is our first simulation. It shows a plane of magnetic field lines. As of now, they are not doing anything. We can move the plane around using our mouse, but we can also add a current, a standing current to our plane. And as you can see, we can also move the standing current, and all the arrows behave like magnetic field lines, and they will respond to our movement of the current. We can also adjust the value of our current, and you can see all the arrows respond to the current just like the magnetic field lines. And this can build up a very good intuitive sense as to how a current will affect the direction and the strength of the magnetic field lines. We can also change the direction of the current like so. And we can also add circular currents. We can remove the currents if we want to. We can change the direction just like so. And we can also add solenoidal currents. So it behaves like a solenoid. And finally, there is another feature where we can add multiple currents like so. And then as a lecturer, you might want to hide the currents like so by clicking this button. You can hide the currents and you can randomize the current position. And maybe you can just show your students this plane with all of those randomized magnetic field lines, and then you can ask the student to guess where the currents are and what are the types of currents that are involved. For example, if you can see here, we have two different circles here, so this might be a circular current. And then we can show the current once again to see if the students got it right. And likewise, we can also hide the magnetic field strength, randomize our current position, and let our students guess how the magnetic field lines will look like. And after they have guessed it, we can show it again to see if they got it correct. And this is our first simulation, while this is our second one, which shows the movement of electrons in a constant magnetic field. So as we can see here, as usual, we can increase or we can adjust the magnetic field strength. And as you can see, the electrons, they behave differently. As of now, they are turning to the right. But if we change the direction, it turns to the left. It turns to the other side. We can also adjust the X, Y, and Z rotation of our magnets. And you can see the electrons, they behave differently. We can also pause our simulation, zoom out, and then we can see the direction of the velocity and also the direction of the force as denoted by the green color arrow here. We can resume our simulation. We can also hide the magnetic field strength so that we can just show the direction of the electron. And then the students will have to guess what the magnetic field lines will look like in order for the electron to go to that trajectory. And after they have guessed it, we can show it. And the student can see if they got it right or not. So these are our two simulations, and we hope that these simulations can help our students to better understand magnetism in an intuitive manner so that they are not just filled with algorithms and formulas, but they actually understand what is going on beneath the hood.
So, to the viewers, we are 100% sure that our innovation will help our students to understand the concept from this topic. And that's all from us. Thank you.
Thank you.